Hello and welcome to my channel. I am Akram and you are watching Knowledge 360. In the previous video, we had covered the topic of schemas in PostgreSQL database. And in this video, we are going to see the topic of inheritance in PostgreSQL database. Inheritance is one important topic in PostgreSQL database and how we can implement it for our real world problem solving. So we'll see all of them and also we'll cover some examples as well. And also I'll show you some limitations of PostgreSQL inheritance as well. And in the next video, when we cover the topic of partitions in PostgreSQL database, there I'll show you what is the difference between inheritance and partitions in PostgreSQL. So PostgreSQL implements tables inheritance, which allows tables to inherit the structure and also the data from other tables, and it can be effective tool for database designers to model real world relationships more efficiently. So now let's see one basic example first to understand the concept of inheritance. So we create one table called cities, and we know that each state can have many cities, but there can be only one capital city. So we are going to implement this data structure using the concept of inheritance in PostgreSQL database. So let's create the tables first. So for that, first let's set the search path to geodata. Geodata is a schema that we have created to perform all the examples in this topic. So let's first create a table. This is independent table called cities. So table contains three columns. One is name, second is population, and the third one is elevation. And the next table that we create is called capitals table. Capitals table contain one extra column called state, and it inherits the table called cities. So what does this mean? This means that the capital table will contain all the three columns that we have defined for cities and also the data for that table, and it will contain extra column and data called state for the capitals table. So let's create this one first. The table called capital is created. We can verify them when if I refresh this table section. Here we can see the cities table and capitals table are created. So here you can see one icon is there. So this symbol means the arrow to right, that means this table is inherited by other table, and this arrow symbol towards left, that means the table inherits other tables. So the tables are created. Now let's insert some data. First we insert data into the cities table. We have inserted two rows into the cities table, and one more record will insert into the capitals. So here you need to understand that when we create the table called capital, we mention only one column, but when we insert the data we mention all the columns, because the columns are available for this capitals table as well, because we have created this table called capitals inherits the cities. So that means whatever data we insert into the capitals table will go into the cities table for cities columns, and the column state, that is for capitals, it will remain with the capitals table. So let's insert this one first. So the data are inserted. Now let's query the inherited data. So the first example is to retrieve all the cities, also including the capitals, at an elevation over 500 feet. So for that we write the simple query that will query from cities table. So here as per data we have got three records in result sets. So we have got the result from the cities table, and now we retrieve the data from only the non-capital cities. So that means how we can do it? So we can do like this. So we can query, select the column names, and then we can mention from, then after that we can mention one word keyword, that is the only. Okay, so it will retrieve data only from the cities. So when we retrieve the data only from cities, the inherited data will not be returned. So let's query this. So here we can see only the data from cities table are returned, not the data from the capitals table. That means to exclude the data from the inherited table, we can write like this. And when inheritance is in place, so it is very important to know what is the origin of the data. So as we saw in the first query, when we have got three records, so for example this one, so we don't know what is the origin of the data for each record. So how can we get it that which record is originated from which table? It can be capital, it can be cities. So for that we use one system column. If you remember, when we had covered the topic of system columns, we had seen one system columns called tableoid. So here is the one real world example of that system columns concept. So if I query like this, so this tableoid and this typecasting will show me the table name. So let's make the same query. So now we have got the data, but here you can see we have got the source tables. So that means these are the origins of the data in the result set. So for the first two, we have the cities table as the root table, and for the third row, the origin table is the capitals table. So now we'll see some limitations of inheritance. So the first limitation is regarding the constraints. The constraints, only the check constraint and not null constraints are inherited by default. Other constraints such as primary key, unique key, foreign key, etc. are not inherited by default. So for example, if I want to add one new constraint like this called altering the constraint called cities and add the check constraint where population should be greater than 0. So that was not added. So the constraint is added to the cities table. Now if I insert the data into the capitals table, so this should be inserted because we know the check constraint will be auto populated the inherited tables. So that means whenever we insert the data into the capitals table, the check constraint will be in place. So the first record is inserted. Now if I insert one more record where the population is in negative, because it will violate the population check constraint and it will not be inserted. So let's try to insert. So this failed. So that means whenever we create the check constraint or say not null constraint, so it is by default inherited to the child tables. The second limitation is of insert behavior. The inserts are table specific. So for example, if I try to insert the cities data, I cannot insert the state column here because we know in the cities table there is no column called state. The state column is present within the capitals table only. It is not present within the cities. So this will fail. Insertion is failed and it says that column state of a relation city does not exist. After the limitations, let's see some advanced inheritance features. The first one is the multiple inheritance. So how we can perform the multiple inheritance? So for that, first let's create one table called landmarks. The table is created. Now if I create another table called historic cities, within that we can inherit multiple tables, so that is called multiple inheritance, and it inherits two tables, cities and landmarks respectively. So let's create this table called historic cities, and if I refresh this table section, we can see the landmark table was the parent table and it was inherited by tables called historic cities. So when we insert the data into the historic cities, the data will be inserted into three tables. One is the historic cities itself and other two tables are cities and landmarks. Accordingly, we need to provide all the columns for insertion into the historic cities. So let's insert this data. So the data is inserted. So the data are inserted into the historic cities and also the data are inserted into the cities table and the landmark table. And the next advanced feature of inheritance is called dynamic inheritance. Dynamic inheritance means we can anytime change the inheritance properties. That means we can add inheritance and also we can remove the inheritance. So for that we can alter the tables like this: alter table, capitals, the table name and inherit, and whatever the table it want to inherit. And also any moment we can remove the inheritance. So to remove we need to alter the table, alter table, table name, and then no inherit landmarks. So let's see how we can drop the tables. So we know that whenever there is a dependency with the child objects in PostgreSQL, we cannot drop the parent objects unless we use the cascade keyword. So if I try to drop the table called cities, it will fail because we know there is a dependent objects and they are historic cities table, and also we know the capitals table because they are child tables and they inherits the table called cities. So let's try to drop this table. So the drop statement fail, but if we use the cascade option it will drop, and remember it will also drop the child tables as well. So it will drop the cities table, it will drop all the dependent objects. So the dependent objects are child tables, capitals and historic cities. So let's try to drop it. So the table is dropped, and also it says that the cascade for two other objects. So the tables are dropped. If I refresh it, so here we can see the table are dropped. So now let's see the access control in case of inheritance in PostgreSQL. The permission granted to the parent table, it will be applied to inherited queries as well. The grants will not be given to the child tables directly, but when we query the data, so it will be applied for the child tables as well. So for example, when we grant the select on this table called cities to these users, so that means we are giving grant on select to the inherited table called capitals as well. So let's give this grant. So the grant is given, and also we can verify that. So here we can see that we haven't given any privileges to the child table called capitals, but it will still get all the grant for select from the table called cities because it inherits the table called cities. So along with the data structure, it also inherits the select grant privilege. So now let's see the conclusion for the inheritance topic. The inheritance in PostgreSQL provides flexibility for complex data models, but it comes with some limitations that is related to constraints, indexing, and data insertions as well. So it's essential to understand these concepts to design efficient database schemas. So this was all about inheritance in PostgreSQL database. So let's meet in the next video with the topic of table partitioning in PostgreSQL database, where we'll cover the differences between inheritance and partitioning in PostgreSQL database. So let's meet in the next video. Till then, take care. Bye bye.